Welcome back, second part of the conversation about the third lesson on ABM course. Now we move to Python, and in Python we are examining both the folder 4 of SLAP, now we are very close to the final version, and maybe if we have time the folder 5, but maybe, but I want to pay attention making a jump, as we have a break in our lesson for 2 weeks, have a jump to the presentation of the solution for the sequences of actions in the shell SLAP. This will be a final digression today. But first of all, moving to Python, I want to show you the use of the idea of the turtles within Python. We have a library reproducing the behavior of the turtles in Python. So the pen, up, down, the movements, and so on. And a graphic display in this case. Lesson 3, Python. We have here two files with the name turtle in the beginning. One line of work in Python, in SLAP, uses the turtle class, also SLAP, with a problem. Online is not possible to have the screen reproducing the graph of the turtle, because in IPython we are missing of the capability of displaying the kind of messages coming from the class turtle using the Turtle-TK old language. But maybe sometime some nice person will create it. The first version is without display. So it's simple text. And it is interesting that the change from this one to the other one, this Xcode running Python, it is too much complicated. Let me open with idle as always. You see here, I have a class of regular cat. If I add the turtle specification as argument, this class will inherit all the turtle capabilities. Now, in the first version, we do not use the turtle library, so you see that here it is commented. We don't use it. I will explain this currently commented as we move to the second version. This is a crazy program with cats meowing and cat barking. The crazy cat are barking. No problem. Random walk, they move, be crying, they can bark or they can meow. This write commented instruction is about turtles. So the write will be on the graphic screen. Interesting and nice. We have crazy cat inheriting all the tools of a regular cat, but modifying in the initialization the cry from meow to woof. Okay? This is deleting the previous definition. We create an empty list of agents. we ask to the user what to do, and then we create the my cat from regular cat and the my cat from crazy cat, adding both the cases to the cat list. Here I am reproducing the same situation that we have in NetLogo. As we have created how many regular cats, the first crazy cat has as number how many regular cats. We created 3, 0, 1, 2. So the first of the second group is Mr. 3. And the range is until how many regular cats plus how many crazy cats minus 1 as usual, because the upper boundary is not never reached. We are strictly less the upper bound. Okay? Acting, I pay no difference because all are mixed together. In the cat list we have both regular and crazy cats. But I want that they don't act always in the same sequence. So I use the shuffle function coming from random library. And shuffle is very simple to be used. Let's see here. This is interactive programming from random import shuffle. In this case, I have uniquely shuffle imported. A equal 1, 2, 3. Shuffle is not a method shuffle, it's a function. With the H. Okay, mix it. Shuffle is replacing the list. So the old list has been internally modified. And so you understand what shuffle is doing here.
Is there a probability that it returns the list unshuffled, or will it always really be shuffled?
Always reshuffled. Okay. To unshuffle my line of work in SLAP, I keep a copy. Okay. Made with the equal old name colon in parentheses. So I keep a safe list with the original order, and the reshuffle is random, so maybe we can make a reverse engineering of the function, but I guess it is a bit complicated. Okay. So this is only a bit complicated, but no discoveries. We run it. How many regular? 3. How many crazy? 2. How many steps? 5. Creation, and then we have our agent going around and not always crying, because there is a probability to cry. You see here, 20% of probability. If I modify this, they will be always crying. Second version, a lot more interesting. From turtle, import all the contents. Now, regular cat is inheriting from turtle. When we don't specify the parent of the class, the parent is object. Object is an internal class of Python. Why this initialization? Because as we use turtle, we have to initialize the parent with the same address of the child, to have connected the movement of the values of the variables internally. There is a book, so it is a complicated part of Python, dedicated to how to initialize or not the parent classes, because it is not a trivial task. What is very interesting in Python is that an instance can inherit from more than one class. This is very interesting, and I asked to Nicolas if in Java that is possible.
Everything is possible in Java.
No. To inherit from more than one class is...
Actually, you can use interfaces and implement several interfaces,
Sure.
which is a way
Sure.
to...
2 days of work. Green. Okay, but I owe you now 2 coffees for the offense. Okay, let's see. Now this is the same. Now all the actions are both producing text and producing movement. This set X, set Y is referred to the turtle class, so the position. And this right is referred to the turtle class. But pay attention, self-right. So my version of the specification is turtle, because I have initialized my specification as turtle. This is a unique problem to be fixed. We are using a local specification of the class turtle within each of our instances. It's nice. Now a word will be plotted for us. How many? 4. How many crazy? 2. How many step? 5. And you see the pen is down, so the movement are reported and the cries are reported in the screen and so on. Is a bit slow because Python is invoking tuple_tk and tuple_tk is producing the graphic output. But we can do quite complicated operations. I show you my school project. Sorry, we have to nicely exit. This hit enter to exit is cleaning the graphic situation to avoid to have a part of memory filled by no more running code. Let's see this example. Now I launch SLAP in an interactive way. I open the terminal. I move to the folder where I have a local copy of SLAP. The local copy is here. And from this folder, I launch UPython, so in the interactive shell of Python. You see, this is a web page, local, because we are pointing to localhost, my machine, at a port 8888. This is the default port of UPython, and I open this notebook. I, Py, and B means interactive Python notebook. And here we have a unique instruction, a magic one, because in UPython all the instructions starting with the purchase sign are doing behind the shoulders very complicated operations, so they are magic. As an example, from here, writing in Python, we can interact with R using magic structure to interact with R. In this case, Shift-Enter as in Mathematica. Shift-Enter or this sign, this one. Shift-Enter, and now Mr. Slap is interacting with us. As I am working currently on the oligopoly project, my local shell suggests to me to launch oligopoly. My reply is no. And Slap is asking me what kind of project you want to interact with. My reply is school. Just 2 words upon school. A few years ago, I worked with 2 PhD students of educational science about the behavior of little pupils in primary school. You know that 25 pupils together are all adults. Each pupil alone is a wonderful person. When they are together, they can do anything, also kill the teacher, and or kill one of the other pupils. The problem is mainly how to manage the class. So in educational science, we had the very interesting possibility of interacting with 2 different classes with the same teacher, the same teachers, and the teachers were very interested in exploring the possibility of understanding why the same behavior can produce very different effect with a class very close to the previous one. Small differences are creating complexity. And this is the reproduction of the word made using Turtle. Random number seed. How many cycles? 3. You see, we are creating the desks. Pupils are entering in the classroom. A graphic is reproducing the attention they are paying to the teacher. A very, very slow attention. And they are crying something. They are moving. One of the PhD students were very able in design, so we have little female, little male. You see, very, very nice. And all this is generated by the class Turtle, which is importing images from GIF files. Nice. Completely unuseful. Because what is interesting for me is this. But to interact with the teachers, it has been the key to catch their attention. I had another terrible experience with a physician, a medical doctor, that was managing the ambulance calls in the district of Torino. And we, my students, we produced a simulator like this. And it was impossible to interact with him. We created a graphical interface, and anything was fixed. Because if you are outside the computer user, this is for you. It's completely a black box. You understand nothing there. Now you know very well this kind of work. So this for you is perfect. This is a vector containing fixed points, subvectors, and so on. No problem. Better for a non-specialist to interact with this. It is costly to produce this kind of graphics because you have to add a lot of specifications. But anyway, it works. It's not the way of using SLAP I will suggest you. Currently, my best interface is that of the graphs of a network using NetORX library. You will see. Now I stop advertising. But anyway, this is a free product, so this is not costly advertising. This is a specification at the end of each run. Python and UPython 2 is surviving to the end of the running code, keeping in memory all the variables. If we want to do a start, we have to clean the memory, because if we do not that, all the variables of the previous run will survive, and this is not good. IPython has this wonderful structure, restart and clear output. And in this way, the memory is clean and the output has been deleted. And from IPython, we have to exit with close and alt, always to avoid to leave in memory unused part of our creation. And then we go out. Exiting from the shell is terrifying. Control break twice. So it is not a so nice way of exiting. Okay, this was only a digression. And I go back to the menu of our conversation. In SLAP, we have the fourth step of the tutorial about object-oriented programming, many bugs, bug external, plus shuffle. This is a novel, it's not a name. And why bug external? Because when you create code, it's a good idea to split the code in different files. It's simpler, and you can reuse maybe one or more of the splitted files. In this case, we have a main program. Let's have a look to it. You recognize it very simply. It is the sequence of the question sent to the user, and it is the cycle upon time to create, upon the number of bugs to create the instances, and the cycle upon time to run the acts, the actions of the instances, with the shuffle that you already know. And where is the bug specification with all the methods? Here. It is important. And the file is external. Not bad. To clarify the structure. And you already know this part. It's the same, but splitted in two different codes. Files. Okay. Any question? If you import twice the same library, Python executes this command only once, because Python takes note of the imported libraries and refuses to add twice the same library. So it is not a problem. If we have not to pay attention, I have already imported it or not, no problem. Here you have a discovery. You see this underscore pycache underscore folder. This is created by Python. Now I delete it and it will suddenly reappear. And what it contains? Very clear. A version of the bug file compiled, translated in C. C Python is a C structure of Python. Why? It is very quick. If we look in it, I open it at a very low level. It is impossible to understand it. It is directly a content of at the level of the language of the machine. So all these signs try to reproduce the content of this piece of code translated to the internal code. But the strings are surviving, because the easiest way to reproduce a string is the string. Okay? This is for speediness reasons. The main is never translated, because the idea is the main will be continuously modified. All the imported parts are translated. If I delete this, as I run the code, as always, how many, size, how many cycles, the result is always the same. If I go back, the folder cache is already there. Normally, regularly, but very, very strange cases, if you modify bug, the internal translated file is deleted automatically and replaced by a new version. The control is upon the dates. If you are artificially changing the dates of your files, the control is lost. You know that it is possible. It's possible to change the date of the files. But it's not a good idea normally. Okay? So we are now close to the true working slab. Folder 5 is to be examined, but now I jump a few minutes, and then we will go back to folder 5, to this introduction, to show you these elements in a true running program, quite complicated, the oligopolistic model, and I am currently working on it. The oligopolistic model is created and maintained using Git. So I open it from Git, a local copy of Git. Then I have a version online. In Git, you can have different branches. You see now the current branch is development on the IKEA market. It does not work because it is a branch under development, but I have a master branch. The master branch is the basis. And the branch under development will be merged in the master when it will be working nicely. I can open a file editor perfectly consistent with Git. I know two of them. One is Atom and the other one is Spider. Nope. A very diffuse file editor. Can you help me, please? No. Just don't think to that, and in my mind the name will emerge. Anyway, I am, this is an habitude. I know very well Hayton, so I use Hayton. And this is the file system of the project. And I want, so you see is a huge project with a lot of, because behind there is also Slab. And I want to show you, first of all, how to describe the observer action upon the time. Observer action text. This is a simple sequence of names, and it means at each step. So if you run 10 times, this will be done 10 times. Collect the structural data. It is necessary to produce at the end a database with the result. Second, run the model. We are the observer, we are looking at the model. Run the model. Collect time series, because the model is running upon time, so we have to collect time series. Visualize the plot. Visualize net. Don't pause. If I delete the n, at each cycle, the slap code will stop waiting for my consensus to start again. And finally, move the clock. This is the key of anything. The time management is similar to the tick order in NetLogger. What the tick is doing in NetLogger is moving the clock. As you order tick, the clock will make a tick, a step upon time. And this is the same. You see, sure, we have to understand what is behind these orders, but as I have to remind to myself the sequence of the action, this is very easy, self-explanatory. Okay? And the model, also the model is an high-level sequence. As the observer order to the model to make a step, the model opens this sequence. Reset. At the beginning of each step, maybe we have to clean something in memory. So there is a reset. Maybe reset is empty. In this case, I can avoid to write it. And then read the script. Why? Because the content of these boxes is written in a script. A script is a set of commands. For Italian people, the best translation of a script is the copione of a movie. And this is the same. The script of a movie. The script, this is a choice of mine. You can agree or not. The script in my structures is written within a spreadsheet. Why? Because every user is able to open and to modify a spreadsheet. I open the structure now in Finder. Finder is the file system manager. To launch a spreadsheet reader upon this schedule. If you want, you can avoid to use the spreadsheet, and you can run directly the schedule in a text file. The program is working in a I don't know how to explain, in a self-sustaining way. If Slap does not find an XLS file, looks for a TXT file with the name schedule. if also the schedule file with the txt extension is missing, slap is declare the error. If this exists, it is translated in the other one. So the true schedule file is always the text one, this one. But we can write it indirectly using a spreadsheet. And the content of the spreadsheet is this one. This is Excel, but don't pay attention to Excel. You can use any kind of spreadsheet. Now we have a lot of different programs running spreadsheet. The name of the editor is close to emerge. The structure is very simple. The class and the method. The class, a probability, and the method. You see, you have been working tonight or yesterday to create a method to be executed with a given probability. Simple. And a lot of other possibilities. Now we look only to a few. I can have a separate spreadsheet. We have to write a set of instructions. I name this sheet, not a spreadsheet, a separate sheet. I name this sheet with I choose a name, and this is a macro. What a macro is a collection of instructions. And then in the main sheet, I will invoke the macro. Okay? So we have now 3 different levels. The first level is that of the observer. The second level is the macro sequence of the model, invoking the script, describing in a fine graded way the model, and the script is basically contained in a spreadsheet. Sure, we have to write code, mainly the code of the agent, because each model will have different methods. This is a model upon entrepreneurs and workers. The other one was upon teachers and pupils, and so on. So, in any case, we have to write code. Sure. It is impossible to use them. Please, my computer create a model about a class of pupils. Maybe with artificial intelligence we will have it in, I don't know, 20 years, I don't know. Okay. The Financial Times in the morning today published a very interesting article. The title is not light. Business is losing the innovation game. Do you know AlphaGo is a startup, now is a huge startup. Hundreds and hundreds of specialists made by Mr. Google. Alphabet. Alphabet is always Google anyway. It is a trick to pay less taxes. Oh, I have to delete the file immediately. Okay. We are recording and putting online in the world. Anyway. Okay. Zero is the last creation of AlphaGo because Zero is completely unsupervised training. AlphaGo is the code winning the game of the Go with Lee Sedol, the number 2 of the world from Korea. And Lee Sedol then explained, and now I am beating other humans very more easily because I learned it from but AlphaGo Zero never learned from existing matches, learning from scratch, playing with itself. And in 100 confrontation with AlphaGo, won all the games. So the new step is unsupervised learning, and the joke is then a human will have supervised learning from the computers. But is the financial time of today. And The Economist published a huge article upon AI and unsupervised learning last week. So both Financial Times and The Economist are paying a lot of attention to machine learning and AI development. Very interesting from the world labor point of view. And Nature published this week a very interesting collection of open articles. So if you go to Nature, you have to pay. But in this case, they published 3 articles about the future of work. The sentence is this: 63 of the activities that the current primary school pupils will do does not exist now. Anyway, 63%, and the majority. Okay, go to Nature and have a look to this collection of papers. It's outside the goal of my lesson, but I am happy to diffuse this because it is a wonderful collection of papers. And I am closing all the windows of Mr. Git. We finish with 5 minutes of attention to the folder 5 of Mr. Slap, and we will start on November 9th from exactly this point. And I show you the content of Python, of Slap, looking to the online version. I close a bit of programs. The online version, you know, by our collection of links. Anyway, if you lose the reference, remember that jumping to my page, and if you write Pietro Terna in Google, my page is immediately the first row. But anyway, it is Terna Toit, so it is easy to have it. It is also linked to the channel of YouTube where you can find our conversation. And here you have Slap, you jump to the version 3, you jump to the code version, and you see here you have the folder 5. What the folder 5 contains? The novelty is the agent. You saw it a few minutes ago. The model running the agent, and an abstract structure named action group. What an action group is this one. And each box has to be considered as an instance of action group. Here you have also text files coming from the old Swarm tutorial, because I want to underline again that the idea of this tutorial, moving step by step, by simple plain programming to a very sophisticated structure, is not mine. The idea is from Chris Lanton, the main author of Slap. Then Chris moved to do other things, and I don't know what now he's doing, but anyway, he has been the creator of a wonderful structure. We have also a very complicated tools folder, and the tools folder contains strange functions, abstract functions, mainly used to manage the collection of the agents and managing the capability of sending methods to agents. In the final version of SLAP, this is contained in the forbidden folder, $$slap $$. So the regular user has no necessity to look at these strange functions. They are very complicated, very sophisticated, but it's not necessary to use them, to know them. Simply you use them indirectly. And the starting point? No one of this code is starting, because this is the model executing the actions. This is the agent. This is the collection of the actions. These are the tools, and the starting point is always a short file, start file object, and so on, that in the simple structure of folder 5, simpler quotation mark, contains the interaction with the user. Then it launches the model as an instance of the model class, order to the models to build the agents, order to the model to build the action, order to the model to run the structure created building both the agent and the actions. And when the run finishes, we have a message informing us that the code concluded. If you look at this, it is very simple, but pay attention. You have been doing exactly that programming in these 2 days of common work, because you have done exactly that in all the codes, both in NetLogo and in Python. You first of all you have created the agents, then you have ordered to the agent to do something in a complicated way, mixed, and finally you have been collecting the result of the application of the action upon the agent. Here simply it is splitted in very identifiable different parts. Again, I have to underline that these ideas are all coming from the Swarm protocol. So I have simply been translating them in Python to simplify a bit the use. Okay, I guess that it is a good point to stop. We have a huge break. You have time to do the homework. Don't forget to do that. It's not necessary that you do it immediately, but please do it. It's also a way to remember what we are doing. And if you can, dedicate please a bit of time to have a look to the SLAP handbook, the online SLAP reference handbook, just to better discover the structure of this object. In folder 3 today, the work is this one. A last operation with NetLogo, modifying the start for bis basic object and so on file using 2 breaths. You will see how it is complicated to do that, how much it is complicated. And in Python, modifying the 4 basic objects, again with the direct addenda. I ask you to try to create a second version of the movement method, that of making huge movement. Here I wrote jumping, with a tiny probability, so mixing a new method and a random behavior. It is the final operation without the structure of slab. Okay, no pressure in this case, we have a lot of time, but don't lose the time. Okay, for today we stop. If you have no questions, okay, we stop. Goodbye.